just a very quick review or revision of what prisms are. A prism, first of all, is a three-dimensional shape. You need to have that somewhere. So these are 3D shapes. And now there are so many other 3D shapes. Some 3D shapes are not prisms. And so to differentiate between prisms and other 3D shapes that are not prisms, we need to take note of what I want to call the cross-section. Maybe we'll come up with another word. I want us to talk about what we call the cross-section. Right, so a prism must have a uniform cross-section. So a prism has a uniform cross-section, and this is what I mean by uniform cross-section. Let's use an example that we all know. This shape here is called a cylinder. Please draw yours as well. That shape there is called a cylinder. So this is a cylinder. But another name for cylinder is circular-based prism. So we actually name prisms according to their bases. So the base of this 3D shape is a circle, and so we call it a circular-based prism. What I mean by uniform cross-section is that if you look at the circle right at the base, the size of that circle is the same as the size of the circle that you see up there. Do you see what I'm trying to say? Yes. So this here is the same size as that one there. I can actually cut this shape anywhere else. If I cut it somewhere here, for instance, and I take a look at the shape I see, I'll still continue to see a circular kind of base, and that circle is the same size. So this is called a circular-based prism. Tell me, in a cone, do you see a circle there? Do you see that the base is a circle? But if I cut it somewhere there, I still have a circle, right? But what has changed? The size of the circles has changed, right? If I cut it somewhere there, I still see a circle, right? But the size has now changed, right? So that is why this is not a prism, right? So this is not a prism. And the reason why this is not a prism is because the cross-section is not uniform. It is changing in size. So this circle here is not the same size as that circle there, not the same as that one there, and so on and so on. So it's not a prism. But it's a prism if the cross-section stays constant. I think you have a rough idea what we mean by a prism. So this is called a circular-based prism. I want us to draw a rectangular-based prism. You can copy me there. This is my, I know that you don't see a rectangle there because I've drawn it in isometric projection. But we're looking at things from an angle. Right. So please try your best. Try your best and draw something like that. The sides that you can't see, like those hidden sides, you make them dotted. I've just drawn a rectangular prism. So this is called a rectangular prism. A rectangular prism like this one is called a cuboid. Then a cube has all edges equal. Okay, good. So just like the circular-based prism, a circular-based prism is popularly known as a cylinder. A rectangular, I left based there, you can put it, but it's not a problem. So a rectangular-based prism is also known as a cuboid. Right, now let's draw a triangular-based prism. You can start with a triangle like that and drop some lines there that are not necessarily vertical but parallel to each other. Make sure that they're the same length. The other one there we can't quite see, so we make it dotted. So we can't see this one, we make it dotted. We can't see this one, we make it dotted. But I think this one we can see. And so we end up with a triangular. Oh, sorry, that's triangular. Triangular-based prism. Okay, so there is a cylinder, circular-based. There is a rectangular prism, rectangular-based. Now this is a triangular-based prism. Anybody who knows another type of prism that we can draw? There's also a pentagonal-based prism, and a hexagonal, and an octagonal, and so on and so on. So if you want a pentagonal one, you need to start off with a pentagon. Okay, this is supposed to be a pentagon. Right, so I'm going to drop a line here and drop another line there. Make sure they're the same height. Drop that one there, drop that one there. Then there is another one there that we can't see, so I'll leave it somewhere there. Then this I can see, I think. This I can see. And that I can see. That I can't see. And that I can't see. Yeah, but draw a clear one. But I've tried. That's a pentagonal-based prism. Very important. Please write down the number of vertices. How many vertices do you see? Let's use the rectangular-based prism. Okay, so guys, this here is a vertex. Do you see that? That there is another vertex. This here is another vertex. That is another vertex. That's another vertex. That's another vertex, and that is another vertex, right? Many of them are called vertices. How many vertices do you see there? Did you say 8? So there are 8 vertices, right? How many edges? 12. Right. This is an edge. Do you see that? That's another edge. That's another edge. There's another one that side that you can't see. Then there's this edge here and this edge here and those two that you can't see. Then there's this edge here and that edge there and that edge there and that edge there. So those lines are called edges. How many are there? 12. There are 12, right? So there is 12 edges. All right. How many? I'll call them faces or surfaces. 6. How many surfaces are there? 6. You can see there is a surface this side. There's this one here. Then count all of them. There's this one there. Then so altogether 6, right? So there are 6 surfaces. Right. Can we now define a vertex? What is a vertex? Right, a vertex is where 3 edges meet. Please take note. A vertex is where 3 edges meet. Do you see the 3 edges here? That edge there and that edge there and that edge. So edges meet at a vertex, right?